All right, let's get started for today for Tuesday. So again, hopefully you've put your links in here. Again, if you're not able to present today, I know it's sometimes hard with break and working with partners and that sort of stuff. Just let me know. I know the baseball team's away right now, so they'll be presenting Thursday also for this. So try to go through that. So we'll just have you step up here. I'm recording this for the online students there. So you'll see this little camera here. You can move this if you want. But again, most of it is just the screen share. The picture of you is not really that important. So you bring up your presentation. If you have a PowerPoint, we can just download it and run it here. I know a couple of the online students have videos, so we'll walk through those first. We'll walk through those as we go here. So why don't we start with Alec here? Looks like you have this ready to go. Let's see about G1. If you, I guess we talk about presenting and courses that teach you how to present and that stuff. This is not one of those courses. I'm not grading you on your presenting, although it is good to practice and you do learn to practice. But this is more about learning through presentation. So forcing you to do makes you learn about one. So this is what we call learning through presentation rather than learning to present. So again, so I'm basically what I'm trying to say is I'm not going to grade you. If you present, you're doing great. Okay.
Sweet. So our robot is G1, developed by Unitree. Got a couple of pictures up there now.
Yes, so there's a picture of the G1 on the right there. It's supposed to be a humanoid robot. So it was created by Unitree. Unitree is a robotic company. It's based out of China. The G1 has gained traction recently due to its motion control through AI technology. An inexpensive 16,000 price tag makes this robot one of the most inexpensive options for this caliber of hardware.
Yeah, there are some quotes there too, because like 16 grand is obviously not inexpensive, but for like a very sleek, functional humanoid robot that could like be in your house and perform tasks, so it's fairly cheap. And then before the G1, the Unitree's like best known release was the G01, this quadrupedal robot on the right. And the main objective of the company as a whole is to pioneer cost efficient, high quality robots that families across the world can afford, to kind of bridging the gap between robots and affordability. And then the company has also produced B1 and G02 models as well, which are similarly built quadrupedal, like dog-like robots.
So the G1 was designed to be compact and light. It has 23 degrees of freedom, meaning that the robot has 23 different independent ways it can move. With these 23 degrees of freedom, it's able to walk, dance, and interact with its environment appropriately. So it's able to navigate its surroundings. So it's weighing in at about 40 pounds. So, I mean, if you can lift 40 pounds, you should have no problem carrying him around wherever you want, maybe to the park or maybe to grandma's house. I don't know. He's 33 inches tall. Once again, he has 23 degrees of freedom. 7 of those degrees of freedom are within his arms. So he has a lot of motion in his arms. And then he has vision-based AI sensors. And once again, he costs around $16,000.
33 inches tall.
That's what we found on the live. That yeah, there's no way that's right because he's about human height. So yeah, no, he's got to be like probably I don't know. Yeah, that's completely wrong.
Probably about
Yeah, he's got to be definitely taller than 33 inches.
And so then one of its like kind of landmark features was that it was the first robot that was able to perform a kip up, which is this action that's being performed over here. It was able to do this because it was able to utilize real-time motion control because of its AI sensor system. And then future plans indicate that the G1 will be able to be used for things like customer service, assisting in educational settings, and entertainment due to its ability to make social gestures.
Yeah, I guess I was just piggybacking off that. I guess additionally to the kip up, it's also able to like they were testing it, they're able to like kick it in the back really hard. And it's able to like recover without falling over. So I thought that was pretty cool. So I guess we're moving on to what it makes or what makes the G1 unique. The G1 combines high-end features such as AI control and full body movement with unique affordability. It's very easily transportable. Once again, it's pretty light and then has unparalleled versatility, useful from labs to classrooms. So if you were studying this or coding or working with this in the classroom, it'd be easy to carry this around. And then it assists in bridging the gap between research and real world usage of robots. So once again, it's kind of affordable. We're maybe going to be able to have these in our own homes in the future. And yeah.
A few pros and cons of the robot. Some simple pros are it's portable and lightweight, cutting edge movement capabilities, AI driven interactions, and relative affordability. But then cons, short-ish battery life. It's still expensive for like your average consumer, and it's a steep learning curve to learn how to actually like use and control the robot. And then note that the G1 is able to be compact and mobile for on the go, which is definitely a big step towards making robots a part of our daily lives. That being said, the robot has a limited battery life, and there's a steep learning curve for programming and integration, but the potential is evident.
The future of the G1. So it can be utilized in the classroom as a teacher slash teaching assistant. Sorry, Tom. It can be used in nursing homes to help care for the elderly, potentially even as an at-home aid. So potential capability to perform a wide variety of magic show-esque acts on stage. And it has huge potential in customer service and automation of human interaction.
And then to kind of wrap up our thoughts here, we think that the G1 is a great indicator of further developments in robot technology for the future. This technology marks a major advancement in making robots more accessible to general society. The G1 not only displays how much robots have advanced kinetically, but how far humankind has come in its attempts to replicate itself in a repeatable, efficient, and effective manner.
Thank you.
Any questions? Yeah.
Oh, we got questions? All right. All right.
What did you say?
Just
short.
We just said it, yeah, I guess we didn't get into that. We just saw that it was short. That was one of the complaints that we found. It's short, yeah, apparently.
Okay, questions? Now, someone has to ask a question or else we can't go on to the next one. Rule. And
Yeah, throw us a law. What do you got? Yeah, there we go. Oh, that's actually a hard question because absolutely not. No. Thank you.
all right. Makinia, Emmanuel, we'll wrap around to you eventually. Okay, we'll get there. Okay, Johnny, Lucia, you want to go here? You've got a PowerPoint. We'll download that, right? You have to download it, or can it present right there? Okay, well, you will be in charge of it. Sweet. All right. You have to talk together. Thanks for that.
All right, so our robot is this SC01 from Engine AI, another humanoid robot. So this is a humanoid robot that is designed to be a step towards actual human acting robots. In their product video, it starts with engineering lead talking about how like humanoid robots have been not great in the past in terms of like their actual behaviors. For example, bent legs and tiny steps. So a big focus for them was like actual human behavior and performance.
Yeah, and so the characteristics of this robot, it costs $12,000, which is considered pretty affordable for a humanoid robot. I think the last one was 16,000. And the goal was to make it like the average height and weight of a human. So it's 5'7", weighing at 121 pounds. So it is a little heavier, but it's very much so human. And it's got 32 degrees of freedom. So that means 32 independent movements. And a lot of those are in the legs and arms. So each hand has 6 degrees of freedom and each arm has 4 degrees of freedom. So it can move and grab things and yeah. It can walk up to 2 meters per second, which is pretty fast, especially with like the humanoid feature of the walk. We'll have a video at the end showing it. But yeah, and it operates approximately 2 hours on a single charge, which is pretty good. And they have like a quick charge battery system, so it's easy to recharge. And it's built from aerospace grade aluminum alloy, so it's very durable.
Yeah, so the company Engine AI is a Chinese company based in Shenzhen. It was established in October 2023 and it specializes in general intelligent robots and industry scenario solutions. Again, humanoid robots and other related products. The products are aimed at various scenarios like scientific research, industrial manufacturing, commercial services, household use, and strive to promote commercialization and global deployment of humanoid robot technology.
Yeah, so the pros of this robot is it's pretty impressive, like smooth bipedal walking, like it walks like a human. And it's very durable and agile like a human. Well, maybe it's more durable than a human, but yeah, with the aluminum grade alloy and the degrees of freedom. It uses powerful processors and stereo cameras to navigate complex environments rather than using like expensive sensors or acu actuators. Yeah. So that's what makes it more affordable. Like the expensive sensors. It also uh, makes it more accessible for real world applications.
Yeah, and the cons here. This is a paragraph I wrote. I was mentioning more just on the sort of theoretical level here, how I think sometimes robots can be built to act too much like humans when I think the benefit of robots is that they can do things that humans can't. So while the human-like gait is impressive, I wonder if that's what we should be focusing on for robotics. But still a great engineering achievement and obviously it's progress towards other things as well.
And we have a video of it here so you can see how
Yeah. So as you can see, very Iron Man-esque. See how culture influences that. But yeah, that's the SCO1. Questions? Yeah.
Yeah, I know. You like, so I noticed like in that video, he's doing push-ups like on nose, almost like no hands, and then in like clips he had hands. You know if like parts of him are like you're like interchangeable and stuff, or?
Yeah, I think like the hands are detachable. I'm not sure about the feet, but the hands for sure. Yeah.
Yeah.
2 hours. Yeah, battery life. Yeah, one thing I keep thinking about when I watch these is, like where would you use something like this, and how far does it have to go before you? I often think, like different people. I always think like a general contractor is, building houses or doing general contracting, stuff, at a job site, there, so in the morning, when you buy a robot, they're getting to pick up with you, go to your rooms, and you'd say, oh, pick up that one, bro, in the same way you'd have, well, my kids always did this when we were younger, we'd take them to houses and they'd have to do all these jobs, and I think they would have created their stuff to not have to do chores, there. So I'm trying to think of at what level is this? Is this equivalent to, a 12-year-old assistant, or an 18-year-old person who you have to show everything or not? So, but that's in my mind. Okay, let's go down. We went baseball. Let's do the figure 2.
So hello with everyone. Today we're gonna present about Figure 2. Before we start getting deep into this, something that I found even yesterday was, I don't know if everyone has watched the movie. I think it's called Real Steel. So there's a podcast of the owner of this company. We're gonna talk about him a little bit more, but he based his ideas to make the robot based on the movie. So I thought that was pretty cool. So let's start. First, in terms of overview, as I said, the name of the robot is gonna be the Figure 2. The company that launched this robot is Figure. Figure is finally bringing robots on home. Figure is putting learning robots into the global workforce. Figure is taking an AI-first approach to market. This is the first thing you're going to find whenever you log into Figure's AI website. So I think it's also pretty nice. Okay, so getting a little bit into what's Figure AI as a company, what are they bringing into the market, what are they looking into the future. One of the things is Figure is bringing robots home, but I think their main focus right now is, and the mission that is here is build a general purpose humanoid robot that can eliminate the need for unsafe and undesired jobs. We're gonna continue talking more a little bit of who are they partnering with. One of them is BMW. It's really interesting. I think Aaron is gonna talk about it later. But Figure AI was founded in 2022 by Brett Addock. This 2022, this 3 years ago, and they already have 2 robots. So what can they do in 10 years? I don't know. Another question that came out to my mind with this when we were doing this is if their mission is to eliminate the need for unsafe and undesirable jobs, what is going to happen with that market of jobs from 5 years or 10 years to now? Are we going to create more jobs with that, or we're just going to eliminate a lot of jobs? Yeah, something nice about the company in 2024, they were able to raise 675 million in funding, and that's what they, I think, came with the resources to launch the Figure 2 in early stages. Some of the investors is Nvidia, Microsoft, OpenAI, Jeff Bezos. They haven't yet launched the IPO, so this means they're still private, but they're talking to see if they can maybe go public next year. So some of the key products. The first one is the Figure 01. This was launched in 2023. I see this mainly as a test of the company. They were able to launch this with, I think it was like less than a year of production, and like it was really fast. Some of the key things about it, they were trying to maybe test how the robot's gonna work, how the robot's gonna move, but it was pretty like simple comparing to the Figure 2 that is now, I mean, it's not in the market. We were trying to find out if someone has bought this type of robots. But I think we saw there's one person, we don't know the name, we don't know anything, but there's one person that have bought this robot. But yeah, and then they're also right now working on the Figure 02. This is the image that you have here is an AI generated image, which asked ChatGPT, how do you think is Figure 03 going to look like? Based on the findings that we have, they said that the Figure 03 is going to be more as a human. Is even I don't know what type of materials they're going to make, like in terms of the body, but they say it's going to be look more like a human and walk more like a human. Okay, in terms of costs, same thing. We try to look how much the actual price of this robot is going to be. We don't know. As you can see, analysts said there's going to be over $100,000. I think that's pretty crazy comparing the ones, for example, I think you guys were talking about the G1 that is only 16,000. That's not good. So that's why they're trying to, I think, with investors and everything, try to cut that price to 20,000 to 50,000.
So some characteristics that this robot has, it's 5'6", weighs about 154 pounds, so it's a little on the heavier side, but overall it has 41 degrees of freedom, and specifically in the hands alone, it has 16 degrees of freedom, so it is able to move in 16 different unique ways in the hands. And then also it has speech capacity with AI. They originally were collaborating with OpenAI, but then they shifted to their own Helix AI. It has a 5-hour runtime, so it's a bit longer than some of the other ones, and it also has 6 of those RGB cameras, and also can weigh up to 55 pounds. So pretty decent amount there. So something that makes it unique is that it's the first humanoid robot that is being used by BMW. Essentially, kind of like the task that it's performing right now is like putting on sheet metal. And they're kind of like overall testing. BMW is partnering with Figure to see, like, testing them out, seeing if they're compatible in an industrial field. Just basically, the robot itself is designed for heavy labor. It's not just meant for just like typical household chores. It is designed to go ahead and do like the heavy lifting. Some of the quotes here, it has about a 400% increase in task speed for like BMWs. And then yeah, just overall, it's one of the few robots that are like aimed at specifically like warehousing and stuff. So some of the pros is that I think it has a friendly design. I think it's kind of cute. It's just silly. But one of the things that I found really interesting was that its ability to co-work with each other. So it's able to interact with each other. So like the image here was taken from like a clip earlier, where they were assigned to put different foods into either like the fridge or into like the cabinets, and they were able to like give each other the things that were needed to go into the correct locations. Just overall versatility, so it's able to perform tasks such as this, but it's also able to be in the warehouse environment. And then also it isn't prone to like chemical and like temperature exposures, which makes it so sought after in like the industrial field, just because if humans were exposed to those kind of things, that could lead to a lot of harm. And also it is capable of self-correction. So cons, definitely on the costlier side for sure. I mean, especially like even like just outside of like household like consumers, like even for people who actually do work in warehousing and like industrial fields, like that's still expensive to actually like equip yourself with like a team full of those. But definitely a double-edged sword for jobs, because it is helping to try and take away like heavy labor, which could lead to many strains, pains, and then also just like that overall unsafe environment with like chemical and stuff. But at the same time, it is also helping to remove people from that kind of environment. But it is a matter of a question. It's a matter of how we're going to kind of reroute the people who are working in there to give them other jobs or other solutions to kind of maintain that overall employment there. And then a fun fact, as Fabian was kind of mentioning earlier, they were able to create a robot pretty quickly. So they were able to, with their Figure 01 specifically, they were able to get the RBR 50 Robotics Award just because of how quick they were able to do it. So we're wondering if possibly Figure 02 could possibly also achieve an award in the year 2025. Oh.
Any questions?
What exactly is it doing for BMW again?
So it's putting on like sheet metal plates
So
Okay.
like, it's just like, they'll like carry them over and they'll put them in like the corrective spots right now. They're keeping it relatively simple for now, just because they're trying to test it a lot and see how compatible they are and how, they're able to perform those kind of tasks. But yeah, they're kind of like helping with like making the cars slightly, but it's really interesting. Yeah. 55 pounds, yeah. That's a pretty good amount, yeah. Yeah.
Yeah, I was thinking that 55 pound, I always think if I have to carry a 50 pound sack of something, that's not as much as I.
Yeah, I mean, like work descriptions, like one of like the most common one I see is like be able to lift like 30 pounds, but like if you ask people to like be able to lift 55 pounds, I feel like that's not as like, I don't know. I probably couldn't consistently lift 55 pounds, so I'd get tired.
Thank you.
Why don't you talk about the jobs, because I think that it's gonna, like, even if this is $50,000, but companies can pay $50,000 and have something work 5 hours and then charge and work 5 hours and do that.
A lot of jobs are gonna be, like, it has to be creative, I don't know.
Yeah, right, yeah, that's the question, is that, what does that mean? Does that mean some people, whoever, the company owners are gonna get rich or richer, or does that mean everyone is going to benefit somehow? That is an important question, I think, so. Here, I'm gonna, try to do this PowerPoint file for our Sherry and Braden, who are online students. Let's see if I can find this. They did do a, well, did they say they? Oh yeah, there's recordings here, I think. Okay. I think I have to go back into home mode. So.
Strength and limitation.
I don't know if there's some way I was supposed to, where there's automatically played, but I didn't figure that out, so. But you have to put up with me.
Today I'll be presenting a research on the Tesla Optimus Gen 2 robot. This humanoid robot stands at 5 feet 11 inches tall and weighs just over 120 pounds. It represents Tesla's ambitious expansion beyond electrical vehicles into the world of robotics. Most of you likely know Tesla with electric vehicles, but under Elon Musk's leadership, they've expanded into multiple technologies. The company's stated mission is to accelerate human transition away from fossil fuels, and robotics is now part of their innovation ecosystem. The Optimus Gen 2 is Tesla's second of their robots, featuring significant improvements in the first generation. One of its most impressive characteristics is its enhanced dexterity, allowing it to perform complex tasks like folding laundry and packing meat. Design-wise, it features a minimalistic black faceplate and has a slimmer build compared to previous models. The giving it a distinctive appearance that resembles characters from science fiction. Side note, Optimus Gen 2 was named after the main character in the Transformers series. Here, the robot is powered by Tesla's proprietary neural network and advanced computer vision system. The same technology that supports their autonomous driving features, this gives Optimus Gen 2 robot the ability to perceive its environment and interact with objects in a human-like manner. While specific technical specifications are not fully disclosed, the robot is designed for both household and industrial applications.
One thing I'd be interested to see, and I don't know if she mentioned this, but she has a picture of it, is that she's not only degrees of freedom in the hand, but also touch sensors in the hands. And so you can see this has in the fingers, it has touch pads on the fingers. So you can see where it's getting feeling for how hard it's pushing on them. So it'll be interesting to see if others have similar, what you see, if you've seen that other places.
Cost and availability. According to Elon Musk, the Optimus Gen 2 is expected to cost between $20,000 and $30,000, making it potentially more accessible than other advanced humanoid robots on the market. However, Tesla has not announced an official release date yet, so it's unclear when consumers or businesses will be able to purchase one.
I like according to Elon Musk quote for the price, because in my world, anytime you do that, you always double the cost and double the amount of time, because he always underestimates the cost and underestimates how quickly it'll arrive. So,
Cost and availability.
okay, thanks.
Right. What makes this robot particularly impressive is its dexterity at such an early stage of development. The ability to manipulate objects with precision is one of the hardest challenges in robotics. Its distinctive, minimalistic design is also appealing from an aesthetic perspective. Furthermore, being built on Tesla's existing AI and computer vision, expertise gives it a strong technological foundation that many competitors lack. Section raises questions about structural integrity and balance. Additionally, as with many robotic projects, there may be significant differences between demonstration capabilities and real-world performance. The robot also faces competition from other companies developing humanoid robots, such as Boston Dynamics and Agility Robotics. Gen 2 represents an ambitious step forward in accessible humanoid robotics. While still in development, it demonstrates Tesla's commitment to expanding beyond vehicles and general purpose robotics. Our sources include coverage from IoT, Tesla's official website, and Yahoo Tech article in front of me. You will notice that I have inserted a video. It is a video from Elon Musk introducing his robot engineer having been started. So enjoy.
Okay, we gotta do that and see if it doesn't work.
That's good. If you look at that gazebo over there, let's get the party started.
Okay, that was very exciting. Uh, all right. They mentioned the Boston Dynamics one is their main competitor. So why don't we do that next up here? Atlas.
So yeah, we did the Boston Dynamics Atlas robot. Little history of the company. Originally founded in 1992 as an MIT spinoff. It's headquartered in Walton, Massachusetts. Employs over 1,000 staff members. Has a list of famous companies as their parent company. They're probably best known for their Spot, their robotic canine, that's in wide market adoption. And then some history of the Atlas robot. It was originally developed in 2013 as a hydraulic robot. It's evolved into an all-electric design. It takes influence from the earlier Petman robot, as seen in this photo. This is backed significantly by DARPA, which showcases the potential of the humanoid form factor in defense applications. And then Boston Dynamics design philosophy is leveraging the robot's whole body to move with grace, speed, and dexterity. And as you can see from the photos, it has significantly evolved over the years.
Just some things that Atlas can do and about the robot. It's about 5 feet tall. The newest version of it is fully electric. It used to be hydraulic. It's got 28 degrees of freedom. It has been shown to be very agile and dexterous. It can run and do flips and stuff. It's got a 360-degree swivel. Stereo cameras and a laser rangefinder. So it's got pretty good depth perception and stuff. There was a video of it sorting like car parts, so it can lift a 35-pound car strut. And it's also been shown to do push-ups. And like one of the previous robots had the pads on the hands, and I think this one does too. In a 2015 competition, it was able to drive a utility vehicle, walk across some rubble, use doors and tools, and it was able to connect a fire hose and open and close valves. I'll show that video now. I think Optimus was a little better on the music part.
So what makes Atlas unique is agility and movement. It has, as you've seen from the video, it's really good at moving about, super agile. It can do backflips as well. Continual development has over a decade. in this development process. It has gone through a range of iterations. What we like about it is just like unparalleled movement capabilities, as well as coordination and grace, far exceeds normal robotic performance. Challenges. It's primarily a demonstration project. It has no really immediate market purpose as of right now, and then has unclear long-term application of goals for this robot.
Again, it's not actually on the market. It's just a demo right now. But a total cost of development over the years is probably in the millions to tens of millions. A lot of it was supported by DARPA, the research division of the Department of Defense. Boston Dynamics has had a few other well-known projects like Spot, which I think is fairly decently used in the market. An earlier project, which I think was run on a diesel engine, was Big Dog in that top right picture there. And it was supposed to be just a robotic pack animal for the Army. The original purpose of Atlas is an emergency response robot. And I think it is still kind of in that area, but it's mostly just moved to a research test bed.
That's everything. Any questions? No, I don't think there was. It is not waterproof. Came from that. Yeah. Well, thank you.
Yeah, I find this interesting because, again, especially if you were at all in high school robotics, but there's two main ways of driving robots. One is the hydraulics, there where you have pipes and you're sending a hydraulic fluid or at least a hydraulic air pressure through these tubes to drive actuators and stuff like that. And there are some advantages, but a lot of disadvantages to that sort of system sometimes. And then nowadays we often have very strong electric motors and do that. One thing that's interesting to watch, and I don't know if you'll see this on some of these, is that there's two options with electric motors. One is, like in a joint to have the actual electric motor or servo, or actually, right there that drives it. The other thing is to have a bigger electric motor somewhere else, like in the body, and then just run a cable out and do that and pull that by the cable there. And you can, make things go up and down. And again, that's I don't know if you're familiar with any of the old, classic mechanical machines and that sort of stuff, but they were often cable driven because the motors were not small enough there. And I don't know if you've ever played with, biology often works that way where there's a tendon connected to something else that pulls it, and that tendon, pulling on that tendon can move something. So, all right, let's see where we at. We did Atlas, Apollo here. So I think I have a YouTube video for this. Let's see if this is going to work.
Hello everyone, my name is Isabella Diva. Today I will be presenting on Apollo, a next generation humanoid robot developed by Apollo. We'll look at its design, capabilities, and something behind it. Apollo was created by the company called Abtronic. Abtronic is a robotics company based in Austin, Texas. It was founded in 2016 and spun out of the University of Texas Human Centered Robotics Lab. Apollo is a human-centered, general-purpose humanoid robot. It's built to work safely and efficiently in spaces designed for humans, performing tasks across multiple industries. Apollo stands 5 feet 8 inches tall and weighs 160 pounds. It's designed for industrial use today, but with potential expansion into areas like healthcare and logistics. Apollo has a payload capacity 4 hours of light. Its design includes force control mechanisms and LED indicators. Here's a video of Apollo in action. Because it's designed with a human form in mind. Its size and shape are similar to a person, which means we can move easily through spaces built for us using our tools, equipment, and infrastructure without needing major changes. This also makes interacting with Apollo feel more natural. Electronic developed a unique force control system that allows Apollo to move safely around people. It can detect objects and its surroundings, and its behavior can be adjusted to create safety zones. For example, if a moving object enters its effect radius, Apollo will immediately pause its movements to avoid collision. This makes it a great fit for collaborative work environments where safety is a top priority. But now electronics, like most humanoid manufacturers, is focused on industry. Factories and warehouses are a good first step, as corporations have the money and other resources required for pilots. Scaling manufacturing for these projects will continue to drive the price point down, but as it stands, the systems are far too expensive for the home or even care facilities to be a practical route. The long-term goal is to use it in healthcare and home services. Electronic aims to price Apollo for $50,000 to make it viable for small and mid-sized businesses, but Electronic isn't there yet. Mercedes-Benz recently announced plans to use Apollo in its factory. The goal is to improve efficiency and maintain high safety standards in vehicle production. This real-world partnership shows how humanoid robots like Apollo have started to play a serious role in large-scale industry. And it could pave the way for even broader adoption across the automotive world. While Apollo is a powerful and promising robot, it does have a few limitations. It still needs some human guidance or more complex and unpredictable tasks, and it's best suited for controlled environments like factories. The battery lasts about 4 hours, so it needs to be swapped or recharged for longer shifts. Also, its hand precision isn't quite at the level of humans, especially for delicate work. Lastly, it's still in the early stages of real-world use, so large-scale results are limited for now. Apollo represents more than just bus technology. It is a stepping stone toward a future where humans and robots work side by side. With its human-like design, safety features, and growing real-world applications, Apollo shows how robotics can enhance our lives and industries without replacing the human touch. This is the end of my presentation. Thank you so much for listening.
All right. All right, Cameron, you want to go with the V1?
She's here.
Yeah, she's not here. though.
I can do it.
Okay.
Yeah, okay. Okay, yeah, so this is Clone Robotics. It's a Polish company. Um, a bit more on the sort of material science side of things. And they're working towards making a humanoid android robot, which I think is going to be called the Proto Clone. They got a few versions, but they don't really have a working one yet. So yeah, this is, I think it's actually a bit of a hand. They sort of started out with very human-like hands. Their speciality is basically modeling the robot on anatomical humans. So like they have a proper skeleton and they use sort of artificial muscles. At the moment, I think they're pneumatic muscles, which kind of work by pumping air and which causes the shape to compress in some sort of way. So it's kind of like a human muscle. They did mention my myofiber muscles, but on their website they don't leave anything about it. And reading about them, I don't think they've got that working in any sort of way just yet. Yeah, so a little bit about these muscles here. That's kind of roughly how they work. I sort of take a little bit of thinking about it to get my head around how pumping pressure in makes it shorter, but I think it just about makes sense. If you think of it like a football or something, maybe that sort of helped me. Yeah, and those muscles are linked to tendons. So just like, oh, actually, yeah, you can hear the air going there. And yeah, just like it's sort of really modeled. If you look at your own hands, it's super similar to how they've done it there. So I think in terms of like degrees of freedom, it's over 200. It's basically meant to be exactly like a human being. So yeah, there's that. I don't think there's much more worth looking at here. So yeah, that sort of comes with like pros and cons. Like on one hand, it's great; it should be able to fit right in like a human being, but on the other hand, it's sort of limited in exactly the same ways. Yeah. So this sort of links in with sort of AI control. Again, they've not really on their website, they don't really have a lot of like working models. It still seems pretty theoretical at the moment, but they're planning on having it so that it's sort of like a natural language interface. So you'll be able to speak to it and it will be able to reply to you and take instruction, just like a human being, I guess. And yeah, also the AI sort of will control like its actual senses and ability to like, not fall over and that sort of thing. And yeah, I think the reason it's going to be quite important or a bit of a game changer is because it's so like a human being, unlike maybe some of the ones we've seen here where they're sort of just chunks of metal, I guess, moving around. It should be sort of more suited to being safe around human beings. So like it's not going to be like a sort of single action movement. It'll be muscles that work against each other just like we have. So you sort of they're more dexterous. They sort of yeah, should be nice and gentle and soft to touch, sort of, I guess. Also, yeah, given they've made it exactly like a human being, it will be useful for researching, I guess, human beings. Like you'll be able to maybe damage one muscle and see how it compensates, sort of, down to study actual injured humans. And then, yeah, in terms of like actual applications, the fact it's so much like a human, should be able to fit right in without any adaptations to like the workplace, which I know, yeah, as Johnny said, it's like good and bad. There's not really like you're not really solving the problem of you're not really improving the human by very much. I also think it's weight. They didn't have it listed, but they had the weight for their hand, which is like the sort of fully developed thing, and it was like based on what that weighed versus a human hand, I think the entire humanoid robot would be about 150 kilos. So yeah, that's a lot more than yeah, most human beings. And yeah, some of the challenges they've got, obviously coming back to that weight thing, it's all powered by compressors and sort of pneumatics. So that's bulky, heavy, takes up a lot of energy. Also the materials, because it's sort of working on stretching and filling up these sort of air sacs as muscles, that will sort of fatigue over time. And then as that material sort of ages, they'll sort of become weaker, potentially break. They've not actually, they're working on having a sort of self-healing materials, which I think they're making steps in that direction, but at the moment, that's not really something they can put in production. Yeah, and also just the complexity of having the amount of computing power to actually run a complete pretend human being with all the sort of like sensors and inputs, and like the number of different joints and things is quite exponential compared to some of the other models. Yeah, so this is a little video of sort of full body one here. So you can see it's quite freaky. It's really human-like, not very functional. Yeah, I mean the music doesn't help, but it's like quite eerie. Like you can imagine if that actually worked a bit better. It's sort of looks very like a human. It's a bit freaky, like the feet and the joints and things like that. They said they have to put a mask on it to sort of try and stop that uncanny valley effect of something that's almost human that's not quite. So yeah, that's the clone Android V1. It's pretty much all I have to say about that. My sources are here. This one here, source three's got some information about the sort of way more advanced artificial muscles, which again, I don't think that's what they've used in their prototypes, but pretty interesting. It sort of seems that they're making actual muscles that will work like human muscles rather than air sacs. Yeah, I think that's pretty much. Yeah. Any questions? Yep. Yeah, off the top of my head, no, but I could probably work it out. Like it's a relatively new company, and they've sort of got like a really like the hand that works. I also don't know if the hand's controlled, like how much that's an independently working AI powered hand and how much is just computer controlled. But yeah, I think I sort of get the impression their website had like their research section, so you might be able to get all their stuff about like the actual like the hardware, but also the software and stuff that's gone into it. And at the moment, that's sort of down. There's not really any information on there. So, yeah, I'd say quite a while until this sort of thing's walking around screening people. But yeah, any more questions? Nope. All right, great.
Okay. I always put this one on there because it's so new and stuff, but it was so kind of different that I thought we should look at something because a lot of the other ones are just kind of, similar. So I think that was a good job with that challenging one, I thought. So, all right, and then I think we just have one more here from our remote students. Let's see if I have.
Hi, my name is Tom, and I'm it's called HMND. The HMND-01 is a new humanoid bot made by a company called Humanoid. It is built to work with people, not to take their job. It's about the size of an average adult, standing 5 feet 9 inches tall and weighing around 154 pounds. The idea is that it can help out in places like warehouses, for the it can also carry up to 33 pounds, which is enough for many basic jobs like moving boxes, stocking shelves, or handling parts in a factory. It uses smart AI to move through tight spaces and do tasks carefully and accurately. One of the coolest things about HMND01 is that it is modular. That means you can switch out parts, like its arm or tool, depending on what job it needs to do. It also has changeable outer covering so it can work in different environments, like a clean store or a dusty warehouse. The company behind the box, Humanoid, was started in 2014 by an entrepreneur named Martin Fogel. The goal is to help solve problems like labor shortage and aging workers by creating bots that can do some of the heavy lifting. The price of HMND 01 is between 50,000 and 100,000, depending on how you customize it and how many you buy. Thank you for taking the time to learn about my humanoid robot, HMND 01. Below are my references.
All right. Oh, and we have to go at the top because we've got to go back here. So let's do our final presentation here. Okay. Get started. You get started.
People that with yeah, hey guys, we with my partner Emil did the robot called Mobile Aloha. So in the picture you can see that's kind of like it looks like. So kind of it's like fancy protest. So you can like oh, slideshow. Shoot. So we'll discuss the overall description about the robot, the guys who created that, the company who provide support in order to happen, and just general characteristics, uniqueness about this robot, and cons and pros. So it's supposed to be my partner slides, but so overall description of this robot is that's advanced imitation learning robot for mobile manipulation. So the traditional imitation learning excels at tabletop task, but lacks mobility and full body control. So you can see in the picture, it's not like actual robot. It's more like limited in every move they can do. So the best about this robot is you can literally teach this robot what you want to do from him, but in order to do this, you need to be in his manipulation. You need to be controlling the robot and do every step you need to do in order to teach this robot to do task you want to do. Like if you want to cook something, you'll firstly do it by yourself with this robot on and make everything. Hey, sorry. We start without you.
Yeah.
Want to continue the slide?
Okay, yeah, so the overall description about traditional imitation of using like Excel's tabletop tasks, but it lacks full body control. It extends the local system with a mobile base and a whole body to the operation interface. And then it also enables learning of bimanual mobile tasks like using elevators, opening cabinets, and raising pans, yeah, like that. And then also has like 50 demos per task, which boosts the success rate up to 90%. And it uses behavioral cloning as an existing data set for enhanced performance.
Okay, so this is the awesome people who made this happen. So we have on the left two PhD students. So Zipin Fu is senior at his PhD program in robotics and AI. Tony Zhao, who is sophomore in the same PhD program. And we have advisor who is run one of the robotics labs. They all from Stanford University. So yeah, collaboration between Google and Stanford University making happen again. So I mean, well-known companies, we all know who are they.
So general characteristics of it has it's 5 feet tall, 176 to 220 pounds. And then it has a jaws 70 OF arms with 3-finger grippers, and it has a wood mover base for all body movement, and has a depth cameras, wrist cameras, RGB for precise vision, and then has a human teleoperation for data collection, behavior cloning for autonomy, and it's also designed for house chores, cooking, cleaning, and so house chores. Uniqueness, by manual dexterity, which means combining two arms with a mobile base for complex full body tasks, and it's also trained by humans through demonstrations, doesn't require manual coding, and it also has a success rate of 90% with just 50 demos per task. And it's the cost fully equipped of 32K compared to like the most robots that are, more expensive, 100K, some are lesser than that. And then it also it's versatile, can load dishwashers, open cabinets, plants, and more.
Okay, so now we will talk about cons and pros about this robot. So I will quickly skim through all the cons. So we'll start from it's huge. So one of the physical limitations, it's huge. So we have dimensions. So I will use European metrics. So it's 90 centimeters. So meters about half of me, and 135 centimeters, which is kind of like this size. So that's kind of almost the size of human. So, but well, it goes because they have like a little bit dimension or dispersion, so it doesn't precisely move as humans. So when he turn around, for example, he has like 10 centimeters error. So literally, if you turn around, he'll be somewhere here, and with his dimension, he literally can like crash some of your kitchen stuff. So again, his arm is not as huge and is not like changing our size, so it's limited. So, for example, if you want to reach the top shelf, he will not be able to do so. If it's not in the same height, he can't do it. So that's these guys can work on in the future. One more is he can multitask, but in order to make him learn something, he can learn multiple topics at the same time. So you always stick to one topic in one time in order to improve something. And the worst part is the result of task he was specifically taught was not as great, so only 40% for literally just cooking. So that's one field it can be improved a lot. And even with dimensions, it weighs about like 190 kilograms, which is what, 200 pounds? Yeah, around 200 pounds. So not easy guy to lift. Yeah. So the pros, because we've done it, so I want to more stuck on the best part of this robot. So the kind of easiest part, this robot is learning not by coding it. So it's kind of make easier to him learn new stuff. It learns through demonstration. So you can either show him what to do with multiple tries, or you can literally be in this like suit and show him what to do and he will remember it and done. So comparatively low cost, or 30 grand for kind of this suit is kind of good because the guys on the market is selling it for around like 200 grand. Again, it's open source, so everybody can use it, upgrade it, and make the impact. Again, multitask. As soon as you teach the robot, he doesn't forget what to do, so you can teach him a lot of tasks to do. So that's kind of interesting part because people with limitation can use it as a suit again. So it's stable, it's heavy, so you'll not like fall, and you actually can do the same like kitchen stuff, controlling the robot. So that's kind of another way you can use this robot, not just like so yeah, it's super flexible and you can literally touch any task you need as soon as you show it. Another one is they have in the paper, they have the high five kind of project. So this one shows kind of potential future for interactive with humans. That's kind of cool. Again, it's stable, it's mobile, it's moves with the same speed of human moves. He can run obviously, but this he can walk slowly as a human. And again, affecting learning. So yeah, we can literally, it's easy to learn. Even small children can teach this robot as soon as they have the same size as this robot. So yeah. Next one. Yeah, thank you for your attention, guys. Any questions?
So if it's washing dishes, is it waterproof then?
Yeah.
Yep. All right, thank you.
I like that robot because again, it has, I don't know if you had a picture of it, it has the unit where you can actually almost get in, behind it and control it and pick it up. To train it. You train it, you show it how to do things there. I just been looking at this Lee robot, which was a little robot by Hugging Face here. Let me see if I can grab a video of it. And my thought is to build this over the summer and then work with maybe students next fall on a little project with this. Let's see if I can find the intro here. This is someone who built this, but it's a little robot. Again, that he builds with the servos and stuff. And again, it runs this AI, this stuff. Let me get to there. Okay. So you can try to program it to do things, but the real power comes, it's really hard, it's challenging sometimes to program all these motions. The real interesting things are when you show it, you train it with another thing. So you use this object and then you have one version of it that you move around to grab things, and then it learns, it runs, again, neural networks here, and will learn how to train something else here. So let's see if they can do this. So again, as they're moving one, they're trying to pick up something. So they're doing it, they're operating kind of one arm to pick up another one. And again, similar thing, you have to do it like 50 times, but within 50 times, it can kind of learn to do these sorts of tasks. And I saw one version where now they have a language model. So you program a prompt, you do it, and then it learns those prompts so that eventually you can just tell it to do things. It'll do it, sort of stuff. So I'm hoping maybe next year to be able to work with something like that. because I don't have $30,000 to buy an actual standing robot yet. All right, Thursday, we're going to be doing the learning activity. What we're gonna do talk about some of these big questions here, and you know, what emotions, intelligence, creativity, souls, you know, does a robot have a soul, that sort of stuff. And I said there wasn't a discussion, but I'm deleting that because originally it was, we would use something called Jamboards tomorrow, but those are gone. I didn't know they went away. So we'll have you do some research there. And then we'll try out some samples. I'll try to update this list here to see what we can do as far as creativity, but then we'll also look at these big questions, have you post to the discussion area what you think about some of these big questions, you know, emotion, empathy, what does it mean to be this? There's a whole area called effective computing there, and simulated versus real emotions and stuff like that. So we'll talk about that on Thursday. We'll also talk a little bit more about the final project on Thursday and help you with some prompts and stuff like that for that. Okay? Good presentations today. Good job. See you on Thursday.